Hi, everyone. My name is Tim Beiko, and I work at the Ethereum Foundation, where I mostly facilitate all core dev calls and protocol developments. So I'm excited to be taking some time today to talk to you all at ETHShanghai about how Ethereum governance works. Um, so let's get started. I think when you talk about Ethereum governance, the first thing to define is what is the thing we're actually defining. And I think there's two things in practice that we end up governing. The first is the set of protocol rules for Ethereum. So these are, all of the rules that the different Ethereum clients implement that allow them to connect on the network. I'd say, you can kind of break those down further between the rules that clients have to implement, which are like the specific protocol rules around consensus. So everything that's covered in EIPs in the yellow paper or in the technical consensus specifications. And then we have this other set of specs, which are more kind of nice to have, which discuss sort of how nodes interact with each other. So things like the networking layer, things like the APIs that are exposed to users, or how consensus and execution layer nodes communicate with each other. But then if you have all of these protocol rules, the other thing that matters is which specific instantiation of the Ethereum protocol are we talking about? And in practice, when we talk about Ethereum governance, what we refer to is the Ethereum mainnet. So this is the network with like chain ID 1 that has all of the balances that we think about and all of the applications that we also think about as being deployed on Ethereum. So this is what effectively is being governed when we talk about governance. And most of my talk will basically focus now on like who are the different stakeholders that govern Ethereum. This kind of image shows you, starting from the core, if we've defined what is the thing we're governing, what is like Ethereum, I'll go sort of towards the, from the inside out towards each of these stakeholders to sort of explain what the role is in the governance process. So the first that's important to note is what we call, core developers. And this is effectively a mix of people working on the client teams, researchers, and anyone else who sort of contributes to Ethereum. I would say on, like a longer or like broader basis where they're not here for just a single change that they want to implement, but they're really trying to like maintain the network over a longer time horizon. And in practice, we have, 10 or more of these client teams that are split up across a bunch of different companies and organizations around the world. We have researchers from academia, VC, and on from companies, from the EF, and a bunch of just, people who will show up in our Discord and start contributing. And I think it's really valuable to keep the set loose for a bunch of reasons. And Afri, which is the person who wrote the comment on the screen right now, sort of explained this really well in a GitHub thread where another project was trying to have a very formal rule of like what a core dev is. And I think he makes a really good points there about like, what are the things that you get from this informality, even though it might be really hard to discuss, like, or to define exactly what a core dev is. And one thing that's really important is just having a general level of transparency when discussing protocol changes. So we do this by trying to live stream and record every sort of public conversation around protocol changes, having public forums like ETH Magicians and ETH Research as well, where a lot of proposals get discussed. Then, if you have these client developers, these researchers that are focused on like the entirety of the protocol, the next layer out is EIP champions. These are people who come and have a specific change you'd like to propose to Ethereum. For those of you who may not be aware, EIP stands for Ethereum Improvement Proposal. So this is like the template or the standard that you use to propose a change. And if you go to eips.ethereum.org, there's the whole template there that walks you through the entire process. And in practice, filling out the spec is kind of the first step. If you have like a larger change or something more complex, as an EIP champion, you'll end up working with these client teams or core devs to like define and iterate on your change. Because at the end of the day, the things you want to do is like show that this is a valuable feature, show that it's sound and that there's no technical risks, and then kind of create momentum around it. Show that there's a lot of people who want this now. And in practice, I have some images below, that sort of show that like people usually come up, they have this new idea. There's often some security risk. It's often a DOS factor. And if they spend a ton of time, then like, they'll iterate on a proposal, get some feedback, and implement it and potentially, have their EIP included. So we see this last image here is this thread that we use for EIP 1153, which just got included into the next hard fork. So the logical question here that comes up a lot is if, core developers and EIP champions are the ones who write all the specs and codes, does this mean they effectively control Ethereum governance? And my answer is no. And we'll spend the rest of the talk walking through why that's the case. So again, coming back to like my sort of diagram from earlier, it's important to note that like, even though core devs and EIP champions might have a more formal role in the process, the rest of like the stakeholders here have like a huge weight in it and can massively influence things. So the first, set of stakeholders outside of this is like consensus participants. So these are either miners or validators on the network. On Ethereum, these are like the proof of stake validators. And if we have an upgrade, like a set of change that client developers, EIP champions agree should go live, it's necessary for at least some of those consensus participants to run the upgrade. Otherwise, the software just would not activate. And then if there's only a subset that upgrade, or if there's a subset that does not upgrade, what happens is the chain will split, right? There'll be a fork on the network and parts of the network will run the upgrade, other parts won't. And on Ethereum, the way we resolve these splits at the consensus level is that validators on each side of it would gradually leak or burn the other set of validators' balances until they represent less than a third of the stake. And then that chain could finalize with its protocol rules. So consensus participants obviously have like an important voice in the process, but they also don't get a final say on the entirety of the network. The other set of actors that's really important is node operators. And this is why decentralization really matters for Ethereum. Because on the Ethereum blockchain, every node validates every transaction. And this, just as an aside, shows that like validator is a really bad term for what stakers actually do, because you don't need 32 ETH to actually validate the protocol rules. Every single node, even a non-validating node, will run every transaction and make sure that it follows the rules of the protocol. And so if you have a blockchain where only the validators are the ones running nodes, they can all collude together and change the protocol rules without anyone else noticing. Similarly, the smaller your validator set is, the easier it is for them to collude, or in a less nefarious way, just to have a coordinated bug that affects all of the network. On the other hand, if we have a large set of non-staking nodes, then what happens is when a block is proposed by a validator, if it's invalid, it'll be rejected by both all the other staking nodes and the non-staking nodes as they validate it. And they'll lose on the potential transaction fees and rewards that they could have gotten by proposing a valid block. So keeping this sort of equilibrium where there's a lot of nodes on the network, both staking and non-staking, that act as a check, acts as a really good disincentive for anyone to try and sneak in a block or a transaction that wouldn't follow the protocol rules. And then if you go up even beyond that, the next level of things is users. And the way this manifests in practice is people asking, can a single project decide which Ethereum fork would win in a situation where there's disagreement between the nodes on the network? And, just to sort of ground this, what happens is if the Ethereum network forks, so part of the network runs an upgrade or has a bug and the other part doesn't, and they disagree with each other, then at that point in time, all of the addresses, all of the balances, all of the contracts, and the data stored in them gets duplicated on both sides. And the set of like addresses, balances, contracts is what we call the state of Ethereum. And there's some things for which it's, more or less fine to be duplicated on both sides. So for example, the ETH asset, we've seen this in the past when ETH and Ethereum Classic forked, there's still an ETH asset on both chains. It works the same way. You can have, something like say an on-chain NFT, which, has all the data on chain and can kind of live on both sides. And maybe a market, appears to like value them relative to each other. So that's not too bad. But then there's some projects that really need to make a binary choice. So something like a real world asset, like a stable coin, if like there's a single dollar in a bank account, it needs to decide, which token on which chain can actually redeem this dollar. And then similarly, something like an oracle or a bridge reports something from outside the chain back to like back to Ethereum itself or vice versa. And so they need to decide, which price from which exchange maps to which asset on which chain, or if you're an L2 accepting a deposit, which deposit is valid and so on. So all of this, obviously has like a huge say in governance, because as a whole, if all of the projects coordinate together, they can give legitimacy and sort of, minimize potential issues during a fork transition. But that said, there's such a network effect here of having everyone else on your chain that it's really hard for a single project to, unilaterally dictate which fork would be the real one if everybody else is remaining on the other side. Okay, and now last layer of the onion, the community, or what Bankless people call layer 0. I think here, it's worth recognizing that Ethereum or, any other system that we build at the end of the day, it's like this shared reality, and we agree to the properties that it has. And so in the happy case, we can define all these processes to change things. So we have the EIP process, network upgrades and whatnot on Ethereum. But then if we have some extreme scenarios like a contentious fork or some validators behaving and reorganizing the chain that would require social slashing, there's no single way to do this. The community needs to gather together and figure out how to address the solution. And because there's no process here, there's no sort of legitimate way to deal with things. And so you really want to think about second order impacts of the action. So, how does this change or this proposal affect the credible neutrality of Ethereum? How does it affect its stability as a platform and so on? So this is probably, the most vague but most powerful part of Ethereum governance, because it can effectively reshape the whole thing if it comes to consensus, but it's so big and so diffuse that it's really hard for the entire community to agree to a very large change unless there's a pretty urgent forcing function to do so. So hopefully this kind of gives you a better understanding of how all these different groups sort of have a say in Ethereum governance. And now I'll share just some thoughts around how does this look like in practice? Why don't we necessarily feel this more when people are sort of talking about Ethereum or interacting with the governance process? I think the main reason is that ideally, the core devs are the ones who sort of have this burden to listen to everyone else and not push through a contentious upgrade. Because if they do so, they're basically the ones that have to deal with the fallout and the instability on the network and whatnot through the entire upgrade. So they have a strong incentive to not push out a proposed upgrade that's going to potentially fork the network, cause a ton of chaos, and have them have to fix the whole thing. And in practice, we've seen this play out a bunch of times in the past. First time in Ethereum's history was with the DAO, where there was this huge hack where over 15% of the supply was affected. There, the core devs took a pretty neutral stance where they put out the software with the upgrade, but they let users activate a flag to say whether they supported it or not. And while most of the network sort of moved in direction of the upgrade, part of it didn't, and this is where Ethereum Classic comes from. And then after that, there was another hack which affected the most used client team through a multi-sig. And so this was the parity team, which was also led by one of Ethereum's co-founders. So in terms of insiders, these were basically the creators of Ethereum core devs who were majorly affected by this. And so they proposed the change that would effectively reverse this hack. But there was huge community pushback towards this. So even though part of the core developers obviously had a huge incentive to get this in, there was never a formal upgrade proposed with this change because of the strong community pushback. And then we had sort of a milder version of this with ProgPal, so EIP 1057, where there was a change proposed to proof of work mechanics, which core devs, I'd say, were moderately in favor of. The community was strongly opposed to. So again, the change never made it into an upgrade. And then lastly, a pretty big change that happened recently was the merge. So Ethereum's transition from proof of work to proof of stake. This is something where, even though at the time, effectively, all the consensus participants on the proof of work chain had an incentive to not have this change happen, core devs and client teams sort of felt that it was worth pushing this through because basically everyone else, and even a subset of the mining community, was in favor of this transition. So the change went through, it got adopted by the overwhelming majority of the network. There was this small minority fork that it happened as a side effect, but generally, the transition went quite smoothly, even though it was a major upgrade to the network. So I'll close off with some thoughts around the current state of governance and what are sort of the problems or areas that I'm thinking through. The first is that over time, we've had more and more stakeholders involved in governance. So as Ethereum grows in importance, there's major applications and infrastructure providers that depend on it, that not only want to that are not only affected by the protocol changes, but want to actively contribute to them. So we have more and more people that are sort of like part of the conversation. And in parallel to this, we have what I call high-hanging fruits. Like a lot of the obvious quick wins have been done. And so most of the proposals we have or changes we need to do now involve pretty complex trade-offs where you can get a reasonable argument on both sides. So if you combine those two things, there's like more people to align and it's less clear like what the net benefit is of a change, then it's really, it creates more friction to move things forward. And you add to this that like there's more value built on Ethereum. I thought there's more at risk if we do a change. Then the question that comes up is it like inevitable that Ethereum will ossify and have to stop changing at a protocol? And I don't have the answer here, but it does seem to be like the sort of default path given our circumstances. And I'll leave you with that. Unfortunately, there's a lot more we could cover, but I want to be respectful of everyone's time. Thank you very much for taking the time to listen to this. If you have any questions, you can reach out to me on Twitter, so at Tim Beiko, or by email, tim@ethereum.org. And I hope you have a great time at the hackathon. I can't wait to see what you all build. Cheers.